Hello, seniors. Today we're going to start a new topic. This is kind of an easy topic, especially at the beginning, then it gets a little bit more complicated. This is about algebra. We're going to study patterns and sequences. So we're going to start with this topic, which is an introduction to patterns and sequences. And you're going to understand how patterns are formed, and maybe later on we will understand how to generalize an equation in order to find any term of a pattern or sequence. So the objective for this class is to recognize number sequences. So we're going to start this by doing a short investigation, which says the following. Joel decides to start saving money. He saves $20 for the first week, $25 for the second week, $30 the third week, and so on. Copy and complete the table below to show how much Joel saves each week and how much he has saved in total for the first 8 weeks. So we have this table over here. First week $20, second $25, third week $30. So we can keep on completing this. For the fourth week he'll have 35, then 40, 45, 50, 55. So it's always $5 more than the previous week. Then we have the total savings, which is how much money Joel has after all the weekly savings. So for the first week, he'll just have the $20 he initially deposited. Then for the second week, he'll have 20 plus 25, which is 45. For the third week, he'll have 45 plus 30, which is 35, and so on. For the fourth week, he should have $110. For the fourth week, it would be 150. Then 195, this would be 245, Ooh, classroom notifications, don't turn in late your assignments, people. So 195, 95 plus 50, plus 55, so by the end of the 8th week, we should have $300, okay? So for part B, it says, how much will Joel save in the 10th week? We don't have 10th week here, so you should keep on doing this table. That's why I added this column over here. In the 17th week, so we're going to calculate that. Week 9, week 10, 11, 12, 13, 14, 15, 16, and 17. Okay, for the 9th week, Joel should save $60, right? Then 65, 70, 75, 80, 85, 90, 95, and for the 17th week, he should save $100, okay? This is an interesting saving money technique if you want to try this at home, people. Okay, so for the 10th week, I'm going to write as an answer. For the 10th week, Joel should save $65. 65. And for the 17th week, Joel should save $100. Okay. Then part C. How much money will Joel save in total in the first year? So here you need to think, how many weeks do we have in a year? Generally, it's 52 weeks. So we see that we have a problem here. We're not going to do this whole table until we get to the term number 52. We're going to waste too much time. So here is when the concept of patterns and sequences get into action, right? We need to find a general formula that lets us calculate the amount of money saved for any week, right? For the cases where the nth term is too big. For example, in this case, which is 52 weeks. And not only that, we don't only need to calculate the 52th term, but we also need to calculate the sum of all of the previous terms until week number 52 in order to know how much Joel saved in total. Okay, so I'm gonna show you the formula used to generalize this equation, and then we're gonna study more in depth how this where these formulas come from, okay? So the first formula, which is to calculate the term number 52, is like this. un, which is an nth term, equals u1, which is the first term of a sequence, plus n minus 1, where n is the position we want to find, times d, which is a common difference. If you look at this table over here, you'll see that if we subtract each term, 25, each term by its previous term, we will get, for example, 25 minus 20 is 5, 30 minus 25 is 5, 35 minus 30 is 5, and so on. There is a common difference between a term and its previous term, and that's what we use as d. Okay, so the common difference in this case is 5. u1 represents the first term of the sequence, which in this case is 20. n, as I told you, represents the position, which in this case would be 52, because we want to find how much Joel should save in week number 52. So un represents the value of that term. So if we apply the formula, in this case it would be u52, the term number 52, equals u1, which is 20, plus n, which is the position of this term, which is 52, minus 1, times the common difference, which is 5. If we calculate this using our calculators, you should get 20 plus 51 times 5, $275. That means that Joel, for week number 52, he should put into his piggy bank $275. But that's not the answer for this question. The question asks how much Joel will save in total for that week. So in order to calculate that, I'm going to show you a small trick. If you look at this column over here, this is a sequence, right? So if you, for example, add, here we have 8 terms, right? If you add the first term with the last term, how much do you get? 20 plus 55, this gives us 75. Then if you add the second term with the second to last term, this would be 25 plus 50. This is still 75. And if you keep on doing that, 30 plus 45, 30 plus 45 is still 75, and so on. This 35 plus 40, 35 plus 40 is still 75. So you see that by adding the terms in that order, this sum is a constant number, in this case 75. Okay, I told you that we added this 8 terms, right? How much is this in total? If we multiply 75 times 4, we get the total addition of these numbers, which is 300. Okay, that's the addition of all of these terms, which we can visualize here. 300 is the total saving for the 8th week. Okay, so we can, from this small problem, we can make a small deduction of the formula for the sum of n terms by doing this. The sum, what did we do to sum the first 8 terms? What we did was we used 8 terms, but we did 4 sums, okay? So this is 8 divided by 2. It's half of the total numbers we used, times. And what did we do? We grabbed the first term and added to the last term. And we got a constant number each time by doing that, which was 75 in this case, right? So this would be u1, the first term, plus un, which is the last term. So s of 8 is 8 divided by 2 times u1, which is 20 first term, and the last term in this case is 55, right? 55. If you do this in your calculator, you will get that the sum of the first 8 terms of the sequence is 300. Okay? So, if we generalize this formula, the general formula would be S of n equals n divided by 2 times u1 plus un. This is a formula to find the sum of the first n terms of a sequence. Sorry, this is not 8, it should be n. u1 plus un, okay? So this is for the sum, and this formula over here is to find the nth term of an arithmetic sequence. Okay, so if we go back to the problem, we want to find the total money saved in the first year. So what will be the value of n? The value of n should be 52, which is the week, right? So we want to find S of 52, and this would be equal to n is 52 divided by 2 times u1, our first term of the sequence, is always 20, plus un, which would be u52, which we calculated here, the money saved in week number 52, so this would be 275. So we calculate S of 52, and we'll get the total money saved for week number 52. This would be 20 plus 275, and this gives us $7,670. So in total, we would have saved $7,670. You see how we could calculate this without having to complete the table manually and wasting our time. This is a general form for you to apply in different situations. From this same reason, I will ask you, and try doing this on your own, how much is the sum of the first 100 numbers? That is 1 plus 2 plus 3 plus 4 until 100. If you understood this concept, by applying a very short formula, you'll see that it's very easy and quick to calculate the sum of the first 100 numbers. The answer is, if someone does this, let me do it quickly, this would be, the answer is 5,050 if you want to try doing this. Okay, I'm going to leave it there. There you go. Then we already did this was part C. So in 52 weeks, the total S of 52 is $6,770. There you go. Then part D, how long will it take for him to save a total of at least $1,000? A total of at least $1,000. So we're still talking about the total savings. So in this case, as we already know the general formula to calculate the sum, we know that the sum should be, I'm going to put part C here, the sum should be 1,000, right? So 1,000 should be equal to the formula n, which we don't know because we want to know after, or how long it will take him to save that money. So n is our variable here, divided by 2 times u1, which is always 20, plus un. We don't know the value of un here, right? Okay, so we're having a trouble here because we have two variables, n and un. But if you recall this formula we've seen before, you can see that we can replace the value of un by this, and we'll get only one variable, which is n. So if we do this, 1,000 equals n divided by 2 times 20 plus, I'm going to use, better if I use brackets for this, un is according to this formula, it's u1 plus n minus 1 times d. But we know that the value of u1 is 20. We know that the value of d is 5 in this particular case. So if we do this again and divide it by 2 times 20 plus n minus 1 times 5. And then we solve this. This would be 1. I can take the 2 multiplying here. So this would be 2000 equals n times, this would be 40 plus, if we do the distributive here, this would be 5n minus 5. So then we distribute the n and we'll get 2000 equals, we can add 40 in negative 5, this is 35, so this would be 35n plus 5n squared. If we order this, take 2000 to the other side, we get 5n squared plus 35n minus 2000. We can divide all of this expression by 5 and we'll get 0 equals n squared plus 7n minus, this should be 400. Yeah, 400. So we get a quadratic equation in which if we use the calculator, remember how to solve this in the calculator, it's menu equation, polynomial, degree 2, and then you plug in coefficients. So this would give us two values of n and 1, and 1 and n2, which are, let me do this quickly, 1, 7, negative 400. This gives us 16.8 weeks. Remember, we're talking about weeks. And as a second value, negative 23.8 weeks, which is not valid, right? Because we cannot have negative number of weeks. So the real answer is 16.8, right? But if we want to round this to an integer number, we would say that n should be 17 weeks. So by week number 17, we would have a total of $1,000 already. Okay, so that's it for part C. Sorry, that was part D already. This is D, so this should be D. So 17 weeks is the result. Then it says E. Try to determine a formula for the amount of money Joel saves each week. Let M represent the amount of money he saves each week, and N represent the week number. Okay, if you realize this formula that we're asking part E is this, the one we have here on top. Okay, that's the general formula to find the amount Joel saves each week. Okay, if we want to write this using the notation it asks here, we would say that this is the same as saying M equals 20 plus n minus 1 times 5. Okay, and this would be the general formula in order to determine the amount saved each week. And then for part F, it says try to write a formula for the total amount of money Joel has saved. Total amount. Okay, so we're talking about adding all of these terms. Let T represent the total savings and let N represent the number of weeks. So if you realize what we're being asked for part F is this formula over here, which if we write with the variables mentioned here, t would be the total and represent the number of weeks. So the formula would be t equals n divided by 2 times u1, which is 20, plus un, which depends on the last term of the sequence, right? We could rewrite this un by applying the same concept we applied here, but in order to save time, we're just gonna leave it like that, okay? You may try this on your own if you want. Okay, let's keep on. So that was it for the investigation. Then we have examples of uses of patterns in real life. These are some cases in which you can use patterns and sequences. For example, number 1, predict the population of a country in 20 years. Work out how long it will take to pay off a bank loan. This is a very common application of patterns and sequences. Predict how long a natural resource will last. Calculate the total distance that a bouncing ball will travel. Calculate how long it will take for an investment to double in value. Or maybe a more current application of sequences is, for example, determining trying to predict the number of people infected by coronavirus, right? That is also an application of patterns and sequences. Okay, then we have a definition of number sequence. It says a number sequence is a pattern of numbers arranged in a particular order according to a rule. In the investigation we performed, the rule was that we had to save $5 more than the previous week, right? Then each individual number or element of a sequence is called a term. So first term was 20, second term 25, and so on. So look at this example. It says consider the following sequence: 1, 4, 9, 16, 25, and so on. This is called an ellipsis. That means that the sequence continues indefinitely. Each term is a perfect square, right? This is 1 squared, 2 squared, and so on. The first term is 1 squared, the second term is 2 squared, and so on. A general formula for the nth term of this sequence would be un equals n squared, right? That's how we generalize it. This is like the general pattern or the general formula for this particular sequence. So it says, find the 90th term. If we want to find the 90th term, that would be u19, right? And in order to calculate that term, it's n squared. So 19 squared, which is u19. 19 squared is 361. So that'll be the 90th term. 90th term. Okay, and then for part B, it says, is 1089 part of the sequence? If yes, what term number is it? So we want to know if this number is part of the sequence. So we can write that as, we know that the nth term of this particular sequence is n squared. So if we want to try and see if this is part of the sequence, this would be our un, right? So we're going to write 1089 equals n squared. We don't know if it's we don't know its position. So in order to solve for n, what we have to do is the square root of the terms, right? With square root both sides, and we see if 1089 is a perfect square, and yes, this is 33 and this equals n. So yes, it's part of the sequence. Yes, it is part of the sequence. And the term number is 33. Term number 33. That means that the term number 33 of this particular sequence is 1089. here's a very important thing for you to always have in mind. Remember that n, which is the term number or the term position, will always be a whole number. We cannot have a 3/4 term or a 7.5 term, right? The position of a number is always a whole positive number. Okay, let's see this example. I think this is the last part of this electronic assignment. It says, write a general formula for the nth term of each sequence. So we have 4, 8, 12, 16, and so on. Do you notice any pattern here for part A? If you want, you can pause the video here and try solving this on your own, and then come back and watch the rest. If you see, for part A, there is a pattern, which is that, I'm going to zoom here. If you calculate the difference between the numbers, the difference is 4, 8 minus 4 is 4, 12 minus 8 is 4, 16 minus 12 is 4, and so on. So there's a common difference, right? So in this case, we can write that the nth term, which is what we're asked, the nth term is, if you use the formula, this would be u1 plus n minus 1 times the common difference. So this would be un equals, the first term is 4 plus n, we're just going to leave it like n because we want to find the nth term, minus 1 times the common difference, which is 4. We can develop this equation a little bit more by doing the distributive. This would be 4n minus 4. So this cancels out. So the nth term is 4n. And you see that this has logic, right? Because if you want to find, for example, u2, which is the second term, we would do 4 times 2, and this gives us 8, which is exactly this term over here. Or if you want to find u4, the fourth term, we're going to do 4 times 4, and this is 16, which is this term over here. Okay? So this works. Let me erase this. Then for part B, I'm going to do it here. For part B, we have this sequence over here. 1/3, 1/6, 1/9, 1/12, and so on. Okay, what is the pattern that you can notice here? You see that the denominator is the value that changes. First it's 3, then 6, then 9, then 12. How can we relate these numbers? If you observe this more in detail, you'll see that this is 3. 6, how can you obtain 6? This is 2 times 3, right? Then the term 9 is 3 times 3. The term 12 is 4 times 3, and so on. So you see that you're always, we could say that this is 1 times 3, right? We're always multiplying the n term by 3, okay? So if we write the general form for this equation, this would be 1 over n times 3. You see that n is this term, the first term, second term, third term, and so on. That's why this is a general form, and we could rewrite this as, this is the same as saying un equals 1 over 3n. This would be the general term. And you can always try your answer. For example, we want to find u3, let's say. This would be 1 over 3 times 3. 3 times 3 is 9. So the third term is 1 over 9, and this matches with our exercise. Okay, so that's it, people. This is electronic assignment number 2. I hope you enjoyed this. If you have any doubts, you can ask in the Google Classroom.